This lesson teaches RYA coastal skipper and yachtmaster students everything they need to know about calculating a course to steer. Whenever we're sailing in tidal waters, or where there is a significant current and we wish to navigate efficiently across the stream, we need to offset our course into the tide. If our destination is within sight, and we believe that the set and drift will be relatively constant over the duration of our passage, we can do this very simply by adjusting the course we are steering such that our destination remains on a constant bearing. If the bearing to our destination increases, we need to turn to starboard. If it decreases, we turn to port. If we can't see our destination, we can accomplish exactly the same result by entering it as a waypoint into our GPS and making it the active waypoint. Then we gradually adjust our heading such that our course over the ground, COG, equals the bearing to waypoint, BTW. If your COG is less than BTW, you gradually turn to starboard. And if your COG is greater than BTW, gradually turn to port. You also need to remember what you learned in the lesson about position, that you must plot your new course on a chart to ensure that it does not navigate you into danger. You need to appreciate that your heading, by which we mean the course you are steering on your compass, is not the same thing as your course over the ground. So you don't simply align your heading to match the bearing to waypoint, because you are trying to offset it to allow for the set and drift. Obviously, the stronger the tide, the more you have to offset. And the process of continually adjusting your heading such that COG and BTW remain in line is only efficient if set and drift remain constant, and very inefficient if the tide is expected to turn on a longer passage, especially in strong tides in a relatively slow vessel. Let's take a very simple and slightly unrealistic example to make the point. Imagine a 2-hour passage north at a speed of 6 knots in a cross tide of 3 knots, first setting east, then west. In order to keep ourselves on track, in other words with COG and BTW both constant at 360 degrees, we will need to first offset our course 30 degrees to port, to 330 degrees, then 30 degrees to starboard, to 030 degrees. So let's draw a 2-hour estimated position. After the first hour we will have sailed 6 miles through the water, but will have only progressed 5.2 miles towards our objective, and the same in the second hour. So our speed over the ground is 5.2 knots, and over the 2 hours we will have progressed 10.4 miles. If, on the other hand, we simply steered where we wanted to go, due north, and let the tide carry us first east, then west, then, as you can see from the second 2-hour estimated position, we will progress 12 miles, just over 15% further. OK, so much for winging it on the hand-bearing compass, or GPS. Let's take a look at the formal method for calculating a course to steer. Imagine we want to navigate from a fix A to a destination B, a distance of approximately 6 miles, and at the same time the tide is setting roughly perpendicular to our required ground track at 2 knots. Start by drawing the ground track from A to and through B and mark it with 2 arrowheads, which is the symbol for ground track. Now consider roughly how long it's going to take you to get to B. Is it going to be half an hour, 2 hours? Keep it simple, it doesn't have to be exact. In this example, we're going to estimate that our boat speed will be 5 knots. So it's going to take just over an hour, and we'll draw a 1-hour plot. So plot a 2-mile tidal vector away from A and mark it with 3 arrows, the symbol for tide. We'll call the end of the tidal vector point C. We then arc the distance we will travel in an hour, which is, rather obviously, 5 miles, from point C to intersect the ground track to find point D. Now plot your course to steer, CD, and measure it with your protractor. In this case, it's 027 degrees true. If you imagine that your boat speed were considerably more, perhaps 6.5 knots, you can see that point D moves further away, and you will not need to offset your course as much to allow for tide. In this case, 035 degrees true. And of course, if you were making slow progress, you'd have to offset more, 018 degrees true. Okay, here's a very simple one for you to start with. Plot a course to steer from a fix at the outer end of the transit in and out of Colville to a waypoint at 46 degrees 06 minutes north, 006 degrees west, assuming a speed of 8 knots, and the tide setting 296 degrees at 2.3 knots. Give your answer in degrees true. If you've plotted it correctly, you should get 064 degrees true or thereabouts. Distance AB is 8.6 miles. After 1 hour, you will be at point D, and AD is 6.8 miles. Therefore, it will take you over an hour to reach B. The exact time being 8.6 divided by 6.8 equals 1.26 hours, or just under 1 hour and 16 minutes. Sometimes, when you need to plot your course to steer on a large-scale chart, you cannot plot a 1-hour diagram. You have to scale it down. For example, if you wanted to calculate a course to steer on RYA chart 4F from a fix at the entrance to Endell Bay, 46 degrees 14.70 minutes north, 005 degrees 47.53 minutes west, to Range Head South Cardinal Buoy at a speed of 10 knots, when the tide is setting 220 degrees at 2 knots, you could plot a half-hour diagram. So AC equals 1 mile and CD equals 5 miles, which is how far you would go in half an hour. You just need to remember that in order to calculate the time it will take you to get to B, you need to double AD to get your speed over the ground in knots. Okay, over to you again. Plot a course to steer from Fairway Buoy outside Roselle Cove to Nearer East Cardinal Buoy at a speed of 15 knots with the tide setting 157 degrees at 1.2 knots, and calculate how long it will take to reach your destination to the nearest minute. As I expect you discovered, at 10 knots on this scale, even a half-hour plot is too big to easily fit on the chart. So in my model answer, I've drawn a 20-minute diagram with AC equaling 0.4 miles and CD 5 miles. You might well have chosen 15 minutes or any other interval, but whatever, you should still have come up with a course to steer of around 220 degrees true in a time of 10 minutes and 46 seconds, so 11 minutes to the nearest minute. Incidentally, just to make sure you are fully cognizant of what's actually going to happen, if you execute this course to steer, how far off your port side will sinker east cardinal buoy be as you come abeam of it? Hopefully you answered approximately 0.3 miles. The point being that your vessel will only ever be on the required ground track. Course to steer plots might run for more than 1 hour, in which case, if the set and drift vary hour by hour, you plot a tidal vector for each hour from your starting position A. Here we have a 2-hour plot, with A to C1 representing the first hour's set and drift, and C1 to C2 representing the second hour. C2 to D is then twice your predicted speed. On your RYA chart 3, plot a 2-hour course to steer and calculate the time it will take from the Foxtrot Charlie 3 buoy at the southern end of Dalaglio Bay to the Bravo Bravo 5 buoy north-northeast of Holme Point, assuming a speed of 4 knots and a tide of 345 degrees 0.9 knots for the first hour and 026 degrees 1 knot for the second hour. The answer I'm expecting is 313 degrees or thereabouts true, 2 hours and 6 minutes. You might also need to take account of 2 or more sets of tidal predictions to cover a passage of less than an hour. Imagine that you needed a course to steer for a passage from Port Slade to Dawson Harbour, taking about an hour. You can see that at high water +1 on a mean spring range, the tide will set 3.7 knots to the south-east during the early part of your passage, but by the time you're 2/3 of the way across, it will be setting at 1.5 knots to the northwest. So we would draw 2 tidal vectors, AC 1.85 miles at 120 degrees and C1 0.75 miles at 320 degrees. Of course, there are many combinations and permutations to cover changing streams and periods of more or less than 1 hour and over a number of hours. Until now, we've simply calculated a course to steer in degrees true and have ignored variation, deviation, and leeway, which we'll come onto in a minute. In this example, with variation 6 degrees west, our magnetic course would need to be 319 degrees. Then, if the wind were blowing hard from the southwest, and perhaps an estimated 10 degrees of leeway, we'd have to steer 10 degrees towards the wind, giving 309 degrees magnetic, where we will suffer 6 degrees of westerly deviation, giving a compass course to steer of 315 degrees. Note that leeway is added or subtracted before adjusting for deviation, and when you are applying an adjustment for leeway as part of a course to steer, you add leeway for wind on your starboard side and subtract leeway for wind on your port side. If you get confused by this, draw a wind arrow onto your chart. Then it's pretty obvious what you need to do. You should already know that leeway is the difference measured in degrees between your course and your actual track through the water, known as our water track, attributable to hydrodynamic inefficiencies in our hull and keel configuration. For sailing vessels, the amount of leeway you suffer is a function of many things. The wind strength and your point of sailing. More wind means more leeway, and you'll generally suffer more leeway when sailing close-hauled and on a broad reach, and none on a run. The height, direction, and steepness of the waves you're sailing in. All three mean more leeway. How much you are heeling over. The hydrodynamic efficiency of your hull, keel, and rudder. The aerodynamic efficiency of your rig. How old your sails are and how well they are trimmed. How good the person on the helm is. And a dirty bottom can all have a huge effect. So, for example, a modern racing yacht with a highly efficient, high aspect ratio keel and rudder, slender mast and rigging, new, well-trimmed laminate sails, a top-class helmsman, and a polished bottom, in flat water, in light to moderate winds, will make almost no leeway. Whereas a bilge-keeled yacht with a stubby rig, spray hood, dodgers, baggy sails, and an inexperienced or inattentive helmsman, in a short chop and force 6 on the nose, might make 30 degrees or more leeway. Traditional, by which we mean old-fashioned, motor yachts with high topsides might suffer significant leeway, and so will modern designs at low speeds. But leeway diminishes as speed increases, always assuming that some part of the vessel is in the water and is not behaving like an aeroplane. In theory, you can measure leeway by comparing your compass course with your course over the ground, measured on a GPS, when there's absolutely no tidal stream setting across your course. You might even try to do it the old-fashioned way, by sailing away from a fixed point and measuring the back bearing using your hand-bearing compass. But both methods are pretty much futile because all they tell you is how much leeway you make in exactly those conditions. The only solution is to keep a record of the leeway you've suffered in a range of conditions. Something else worth knowing about is the 1 in 60 rule. If the tide is setting roughly perpendicular across your course, you can calculate how much to offset your course into the tide in degrees by multiplying the drift by 60 and dividing the result by your estimated speed through the water. For example, at a speed of 5 knots, with 2 knots of tide setting you 90 degrees to starboard of your intended course, you would need to steer 24 degrees to port of the required course. If you compare it to a conventional course to steer plot, you'll see that it works. If you're interested, there's an article from Wikipedia explaining how it works, linked from the Resources tab. We've nearly come to the end of this lesson, but before we finish, let's work through a complete solution. Let's imagine we need a course to steer from a fix at 0938 Southern Peninsula Daylight Saving Time on Tuesday 9th of April to a waypoint in Falls Deep Channel. Our boat speed will be 8 knots. The wind is blowing hard from the northwest, causing us to suffer 10 degrees of leeway. Magnetic variation is 6 degrees west. The distance is 13.8 miles, so it's going to take us approximately an hour and a half. Remember to use times of high water Victoria. There's one at 0838 UT, which is 10:38 Southern Peninsula Daylight Saving Time. So the high water hour is 10:08 to 11:08, and the high water -1 hour is 09:08 to 10:08 Southern Peninsula Daylight Saving Time. Today's range is 3.5 meters. At the very outset of our passage, the tide is going to be setting weekly at 286 degrees. But within 30 minutes we'll sail out of the inshore back eddy, and it'll be setting more strongly in mid-channel at 095 degrees. Later in the passage it will be more like 98 degrees. Notice, by the way, that there are not any precise answers. For example, we don't know exactly when and where the tidal stream we're suffering over the early part of our passage will turn, or in the latter part of the passage whether we should use data from the arrows east or west of the rhumb line. You have to use your judgment and experience. Going back to today's range, you can see that it falls between the mean neap and spring ranges for Victoria, so we need to interpolate. For the first half hour it will be 0.8 knots at 286 degrees. For the second half hour it will be about 1.8 knots at 095 degrees. For the last half hour it will again be 1.8 knots, but at 98 degrees. We're plotting 3 half-hour periods, so AC is 0.4 miles at 286 degrees, CC1 is 0.9 miles at 095 degrees, and C1-C2 is 0.9 miles at 098 degrees. C2D is 12 miles because that's how far we'll sail through the water in 1.5 hours, giving us a true course to steer of 043 degrees. The wind is on our port side, so we need to sail 10 degrees to port in order to counteract leeway, and magnetic variation is 6 degrees west, giving a magnetic course to steer of 039 degrees. Finally, deviation at 039 degrees is 1 degree west, which we add, arriving at a compass course to steer of 040 degrees. AD is 12.9 miles, so to work out how long it should take to reach the waypoint, we divide the distance AB by 12.9 and multiply by 90, giving 96 minutes. Of course, in real life our speed through the water might not be exactly 8 knots. The tides won't be running precisely as predicted, and leeway might be more or less than 10 degrees. So it's essential that we monitor our progress. Although we can't expect to remain on the rhumb line AB, because we're first going to be setting to the west of it. Well done! You've completed the lesson on course to steer. Now go on